Hi, and welcome to another Type with Me. Today I want to walk you through an example of LangGraph.js. First of all, I'm going to talk about what LangGraph.js is, what it's capable of, and why you maybe should use that. And then we're going to some kind of examples. I explain you a little bit of the core concepts. We go through an example and see what it actually is and could do or could be capable of. Right, so LangGraph is actually a product like LangChain, and that's actually to build LLM applications. And with LangGraph we can create some kind of an LLM workflow, right? So we can then create nodes, we can create edges, we can create functions that needs to be executed, and it's actually to give or gain control with LangGraph to design agents that reliably handle complex tasks. But by walk you through these examples, you will see why it is being designed to create agents that can handle complex tasks and how you can create these kind of different agents, define these agents, and let them work together, right? First of all, I want to explain a little bit of the core concepts. So nodes are functions that process or transform the state. Edges are defining the flow from one node to another, and the state is the data object passed and mutated through the graph. Is it not wonderful, right? So LangChain and LangGraph are open source projects, open source frameworks, so you can go towards GitHub and you can also explore the examples yourself. So if we go to GitHub, you see here that we have a customer support chatbot, and actually to give support to humans and to handle certain hotlines, for example, it could be helpful to give a lot of knowledge to a chatbot and handle or let the chatbot handle the complex tasks without a human needing to be involved with that. And so below is an example of customer support chatbot. Built as a state machine, it's designed to work with smaller models by giving them context as to what part of an interaction they are in. Reducing the decision space given LLM call has to keep them focused. Entry point is a node containing a chain that we have prompted to answer basic questions but delegate questions related to billing or technical support to other teams, right? And then if we go here, you see that we have a customer question. We have frontline support. So a customer is asking a question. You get frontline support, which is saying, hey, this is a billing issue. If it's a billing issue, yes, then we are calling the billing support. And if it's refunds, then yes, we need to use the refund tool. If it's no, we need to respond directly. If it's a technical issue, then we need to call technical support, and then we need to respond directly. So what is the setup? So first we need to install the required packages. We'll use a relatively small model, so here you use Llama 3.1. We have now newer models that can be used. I think they are higher Llama models, so you need to see. You can use then Ollama for that. I think I also have a video about how to use Ollama. And then you'll also need to set an environment variable named together AI API key, which you can obtain from together dashboard. So together AI is something else. It's always interesting to learn about new things. So the AI acceleration cloud turbocharged training inference on NVIDIA's GPU clusters built with open source and fine-tune your own AI. If we go to products, you see here it has a model library with a lot of cool models. So again, in the example, they are just using this one to get to the LLM models, and you can then use, for example, Llama 4, Maverick, or search for still smaller models, right? All right, so and then we can say here model chat together AI, but you can then, like I said before, use the Llama as well, and then instead of here together AI, you can use here then Llama if you have installed it locally, or you can just use OpenAI or other kind of things. And then we can lay out the graph. So we can create a message annotation, and we can create some state values here. Like a message is a base message array, a next representative is string, and a refund authorized is a boolean. It's important to know, like, hey, we want to do a refund, but then of course the user needs to authorize himself so that he can get the refund. So it's important to see if that action has been done or not, or if LLM needs to do it, we as a human always need to give authorization for that. So this state will be passed to the next execution node, or will be returned if execution has finished. Defining the state looks like this. So we can then annotate it with annotation.root, matches annotation.spec, and then here we have an annotation which is a string and an annotation which is a boolean. ZOT and ZOT to JSON schema validations are important for this as well. I also have a video about ZOT. So again, it's a cool thing within TypeScript. So if I go to zot.dev, for example, see your TypeScript first schema validation with static type inference. So it's also something you can learn yourself. Then we have our initial support. We have our system template. Your frontline staff for blah blah blah. You can chat with customers and help them with basic questions. So you can explain a little bit what that is. And then you say, hey, this is a role, this is a system, content, and then a system template. Categorization system template. You are an expert customer support routing system. Job is to detect whether a customer support representative is routing a user to a billing team or technical support team. So you need to see if that person needs a billing or it has technical question. Then we have here human template. The previous conversation is interaction between a customer support representative and a user. Extract whether the representative is routing the user to a billing or technical team, or whether they are just responding with a JSON object returning a single key called next representative with one of the following values. If we can go here, right? If they want to route the user to the billing team, respond only with the word billing. If they want to route the user to technical team, respond only with the word technical. Otherwise, respond only with the word respond. Then we can invoke the model with role system, content, categorization, system template. We are state.messages, our role user, categorization, human template, and then response JSON object, a ZOT to JSON schema set object with a billing technical response. And then we can return the messages and next representative, which is coming out of our state, right? So next are nodes representing billing and technical support. We give special instructions in the billing prompt that it can choose to authorize refunds by routing to another agent. So again, you have a system prompt where you say that you're an expert billing support specialist. It's really cool to see that you can create specific functions in this case, billing support team and the refund team and so on. And here also you have a categorization system template and a human template. And here is the text billing response dot representative response dot content. And the same thing goes for the technical support. So that's then a function and a state. Remember the core concepts of LangGraph. You have functions, you have state, and you have edges. So you have nodes, and these nodes are then the functions. So here the technical support is a node, and it's been connected towards the edges, and the state goes through it, right? And then finally we need to create a node that will handle refunds. It's stamped out here since it's not a real system, but in practice you could add a real tool here requiring human approval. We use a special error called a node interrupt in order to allow for resumption of the graph later after a human has examined the state and confirmed that the refund is suitable. So for ambient agents, it's important that for certain steps in LangGraph you need human intervention and you need human approval. So I think the people of LangChain have created something like an agent inbox, which is a nice UI UX for interacting with approvals in there. So here you see we are a message with a role assistant and the refund processed. Okay, we can start building our graph. So how do we do that? And setting initial support as our starting node. So that's the starting node. Then you have the billing support here. You have the technical support here. We have the handle refund. Here the handle refund, which can be provided as a node. So all these are functions. And then we can add an edge, which is start, and start goes to initial support. Of course, we need to connect then. So great, now let's move on to the edges. These edges will evaluate the current state of the graph created by the return values of the individual nodes and route execution accordingly. First, we want our initial support node to either delegate to the billing node, technical node, or just respond directly to the user. And use an example of how we can do that. So you have, for example, a builder.add conditional edges, not just here add edge, but conditional edges. We can then see if state.next representative.include billing. We return billing, otherwise technical, otherwise conversational. And that's the object we return, and then we say added edges. We do not use tool calling here for formatting the next step from the history because our model does not support it, but you can apply if here your model does. So let's continue. We then here do builder.add edges technical support, and then underscore end, so that this is really the end, right? Edit a conditional edge. If the next representative is refund, we do refund, otherwise we return end. And you can add an edge, handle refund, and then an end, right? Then we can use a memory saver checkpointer, do build.compile a checkpoint, and then we have a representation of the current constructed graph. Can do something like this at TS Lab. Can use that representative.graph.get graph, image await draw mermaid PNG, and you see that it's drawing this. And it's interesting because then you can with tslab.display.png draw it, and if you are also using a Python notebook or a Jupyter notebook in this case, you can then very easily see if your graph is being constructed correctly before you're really going to deploy it or use it in real code. And we can get the returned value from the execution node as they are generated using the .stream rumble method. Here's an example with a billing related refund query. Because of how we defined our state, the input must be a message representing the user's question. So here we have a message: user, I've changed my mind and I want a refund for order, and then specific order, configurable thread ID, refund testing ID. And if we then execute it, you'll see that it will respond with content. I'd be happy to help you with that. However, I need to check on our refund policy for you. Can you please hold for just a moment while I transfer you to our billing team? They'll be able to assist you with the refund process. And then you see here additional things, blah blah blah, and then next representative billing. Billing support, I'm happy to assist you with your refund. I'll transfer you to our refund team who will guide you through the process. Please hold on for a moment. Refund team, hi, I'm here to help you with your refund request for blah blah blah, and for order and then the order number. Can you please confirm your refund amount and reason for return? Then the human need to authorize a required for refund. You have another step, and then you have end step. Alright, so we can get our state, and then here current tasks, ID, handle refund, human authorization required when, during. So within our current state, you will see here that we have handle refund, and of course it needs to, or you need to authorize it. So what we could do then is update the state. Here you see it, graph.update state, and we do refund authorized to true. Then resume stream. And we can get something like this. Message role assistant, content refund processed. And then you can go through the same kind of thing, but now you are not asking for refund, but you can do the same thing with just asking a technical question. user, my LangGraph computer isn't turning on because I dropped it in the water. And then here you go. Oh no, sorry to hear that. Water damage can be a real challenge. Have you tried unplug it and let it dry out for a bit? Sometimes it's just a matter of giving it some time to recover. And then it goes to the next representative technical. Sorry to hear that. Water damage can be a real challenge. Let's try to troubleshoot your issue. Blah blah blah. And then it gives you some kind of answer. So it doesn't go to the refund, it goes to the technical team, which is cool, right? So it really can determine how it's refund or how it's that or how it's that, and it goes to the right bot or chatbot that can handle this kind of stuff. So it correctly routes it to the right thing. Then we just are going to chat with it. And you see that it just answers things back and sets next representative response. You can see that it just handles that message. So again, a great example of how to use LangGraph together with some kind of an AI workflow and to use it within your customer support, right? So I think that's great. I hope you understand a little bit more what the capabilities are of LangGraph. It's a little bit of a longer video, so it's great that you stick to the last bit of the video. I really appreciate that. I hope you enjoyed it. I hope you liked it, and let me know in the comment below what you think of this video. Do you think it's a great video to explain a little bit of the code so that you understand a little bit better, or if this is not a great format, then please let me know that as well, and I will create other shorter videos in the future. So thank you very much, and I hope to see you next time.